Dear AS level students, hi everyone again, and I wish you all the best, especially in these circumstances that we are living with now. We are today in the chapter of geometric sequences and series for C2, for core mathematics 2 or pure mathematics 2. You'll be starting with identifying what does geometric sequence. We know from IGCSE in O level, that geometric sequence is a sequence that its rule or pattern is multiplying or dividing. This is the old definition, and it's true. But we will define geometric sequence, or we call it geometric progression, arithmetic progression, AP. Now we are in geometric progression. It's a sequence or progression that has a common ratio. If you remember from arithmetic, it has common difference, adding and subtracting. And remember that we read the sequence in this direction now. So the old definition here in O level, we were reading the sequence like this, 2 times what? So we were saying the rule like this, first sequence here that I started with as the first example, 3 times 2. 3 times 2 is 6, 6 times 2 is 12. Now in advanced level, no, we read the sequence in this direction. What do you mean? Common ratio. If we divide this by this, you'll get the same ratio if you divide the next by the previous one. So is 24 dividing by 12 equal to 12 dividing by 6 is equal to 6 dividing by 3? Yes, it's 2. So we say the ratio R is 2. This is the meaning by common ratio, equal ratio. The same for example 2. It's a geometric sequence. Why? Because 12 over 24 it's half, which equals to 24 dividing by 48. So R is a half here, it's half. In general, for any geometric sequence, we can write it like this. A times R, A times R times R, which is AR squared, AR cubed. And the last term, on the nth term, is AR to the power of n minus 1. Where A is the first term and R is the common ratio. As we took in arithmetic progression, arithmetic sequence has an nth term and sum. We'll be studying this today. Geometric sequence has an nth term that is given by this formula or this rule. The nth term is equal to A R to the power of n minus 1. This is the nth term of a geometric sequence. How the questions may come on this? The same logic. Do you notice, if you remember the chapter for arithmetic well? In the sequence 36, 12, 4, part A, write the next 2 terms. So only just in part A we know what's the rule of the sequence. What's the rule? Divide 4 dividing by 12. Is it equal to 12 divided by 36, which is third? So R is third. So what's the next term? Third times 4 is 4 over 3. Third times 4 over 3 is 4 over 9, as explained to you here. Part B, what is the 10th term of the sequence? 10th term. Yes, we can continue here for 10th term, but if you ask about 50th term, 100th term, it does not make sense that you'll be writing them. So we use the nth term for this to write any term in the sequence. So the nth term that we denoted by U10, the nth term is equal to A times R to the power 10 minus 1. A is the first term, which is 36. So it's 36 times R, which is third, to the power of 9. Use the calculator, you will get this value. This is the 10th term. Easy introduction. Example 2. If 4x and 12 are the first three terms of a geometric sequence or geometric progression, right? Look, we are doing now like variant forms of questions. Variant forms of questions. Write the sixth term as a radical 3, where x is positive. He wants x is positive. And a is a positive integer. He wants x is more than 0 is positive, and a is a positive integer. Okay, since the sequence is geometric, so it has common ratio. If you divide the third by the second, if you divide the third by the second, it must equal to the second dividing by the first. 12 over x is equal to x over 4, which is r. Each one value of these two values is r, is the ratio. How do you do this? By cross multiply. X times x squared equals 12 times 4, which is 48. So x equals radical or square root of 48, which is 4 radically 3 in thirds in the simplest form. So the first three terms are 4 radically 3, and 12. Replace x by its value. So what's the value of r? 12 over 4 radically 3 equals to 4 over radically 3, or 4 radically 3 dividing by 4, it's radically 3. So r is radically 3, and a is given 4 from the question. Then we can find, since we have the values of r, a and r, we can write any term in the sequence, simply like this. So he wants the sixth term, which is r to the power of 6 minus 1. So it's a r to the power of 5. Just replace these two values. What you will get? 4 radically 3 to the power of 5, which is 4 radically 3 to the power of 4 times radically 3. Why I'm doing this? I don't use the calculator because it may help me in other questions. As a student, remember this always, we must, most of times even, not sometimes, to be able to do the questions without calculator. So this to the power of 4, which is 3 to the power of 2. Use the calculator here, it's okay, but show these steps. So 4 times this is 4 times 9, and radically 3 here. So what I will have at the end? 4 times 9, which is 36, radical 3. So a in the question, this a is equal to 36, which is positive integer. True that this, remember here that we have a plus and minus. Minus 4 radically 3, we ignored it here. We neglected. It's negligible. Why? Because he wants x more than 0. So here we ignore the negative root. We ignore, since x He wants it what? Positive. Example 3. Example 3 says if the second term in a geometric sequence is 162 and the fifth term is 6, right? The 10th term, right? The 10th term, this is written 10th term, not clear way, in simplest form. If it's in third, simplest form. It's in a fraction, simplest form. Write it in simplest form. Okay, we start with the given information. It's that we starting solving. Second term, which is U2. U2 is equal R 2 minus 1. So A times R is 162. It's equation number 1. Fifth term, A R 5 minus 1, so R to the power of 4 is equal to 6, like given in the question. He wants the fifth term, so I have to find the common ratio and the first term. We have two equations with two unknowns, but the best way we can do these equations in many ways. The easiest way when we have powers in the equations is by dividing them, not by elimination. Substitution may work, but it will be more confusing. Dividing them is the fastest. Why? Look what will happen. If we divide equation 2 by equation 1, what will happen? R to the power of 4 over A to the power AR, A will be gone. Will be cancelling each other's. R to the power of 4 over R is R cubed. By simplifying this is 1 over 27. By cubing root, so R is third. R is third. Look, simple steps. I don't use the calculator even. I don't need it. To answer this question, I need the value of A. We are free to use any of the two equations, but equation number 1 is faster or easier. So by equation number 1, A times third, which is R, equals 162. So A is equal 162 times 3, 486. He wants the 10th term, which is U10, which is R to the power of 9. Just substitute or replace the values of A and R. You will get this fraction in the calculator. Simplify it in the calculator. You will get it in simplest form. 2 over 81. 2 over 81. These are variant forms of examples may come in the exams. As we have some of the arithmetic sequence or series, we have some for geometric sequence or series. When I add the terms of a sequence, I get series. We know this from the previous chapter as AS students. In core, it's in C1, or before this lesson in the previous chapter in P2. To find the sum of the first terms or n terms of a geometric series, we use the rule. This rule, it will be given the formula sheet, of course. It will be given in the formula sheet in the exams. We wish the exams will be run, we don't know yet. Sn is equal to A times 1 minus R to the power of n dividing by 1 minus R, where A is the first term and R is the common ratio. We have another formula for another sum, is called sum to infinity. What do you mean by this? I did help you by writing here quickly. We call an infinite series a convergent series. What do you mean by a convergent series? Convergent series, it's a series, its sum, when I add its terms, I will approach or go to a certain number, real number. The convergent series has a sum, it's called the sum to infinity. What do you mean by the sum to infinity? We don't need to go deep in this, but I just explained to have a clue what does sum to infinity mean in seconds. In the series 1 plus half plus fourth plus 1 over 8 and so on, a is 1, the first term is 1, and r is half, as it's clear. So the nth term is a, which is 1 half times n minus 1. Just focus here for seconds on this. As this n, the value of n, is getting larger as you increase n, what do you mean by increase n? This will be 1 over 64, 1 over 128, and so on. You will notice that when you calculate, so I wrote you a note here, try the first 10 terms, then do other 10 terms, 20 terms. You will see the answers when you add in the calculator approaches this number. So first time, for example, is 1.97 something, then the next 10 terms will be 1.98, the first 10 terms, 7 something. Continue, you are approaching 2 at the end. This is the meaning by sum to infinity. So for example, the 100th, continue the sequence, the 100th term is 1 over 2 to the power 99, yes? 99th term and the 100th. It's a big number, so 1 over this is approaches 0. So this number will be just increased by small values, very small values. It will be approaching 2 at the end as this is increasing. Denominator is increasing. Alright, can we calculate this value? Yes, we can, by a formula. So we have a rule, as we have a rule to the normal sum, let us say, of geometric series, we have a formula for sum to infinity. This is that we denote or represent sum to infinity is equal to a over 1 over r, or 1 minus r. Let's find, when you use this formula, you get the 2 that we were talking about now. Yes, in this series, a is 1, a, the first term is 1, and r is half. Replace these values in this formula. A is 1 over 1 minus half, 1 dividing by half is 2. So the sum of this series is 2. This is the meaning by convergent series, and this is the meaning by sum to infinity. The word infinity came from that you are increasing the values of n. As n is getting larger, so the value will be converging, approaching a certain number, which is 2 in this example. Let's do a couple of examples for today to finish the lesson for now. Then we'll be doing the harder or more complex problems or past paper problems in the next videos soon. Example number 5, the next example. Find the sum of the following geometric sequences or series or progressions. First one, you are given 2 minus 6 plus 18 minus 54 plus 162 minus 486. It's clear that A is 2. It's given here. And it's clear that these are 6 terms. 1, 2, 3, 4, 5, 6. So when he say find the sum of these, so he wants a 6 in this. Add them. Simple English. Add these values. But we are using the formula to practice it. Using the formula of the sum of n terms for geometric series. So A is 2 minus 6 dividing, or negative 6 dividing by 2. It's 18 dividing by negative 6, which is negative 3. So R is negative 3. You'll be using the value of A and R in this formula. A is 2 and R is negative 3. By calculating, you'll get the sum is negative 364. We remember from the arithmetic or binomial expansion before, or arithmetic sequence, this sum notation. So you might be given this notation to be asked to find the sum. This, what does it mean? Find the sum of 10, the 10 terms. We can do this straightforward, but we don't prefer this. The best way, if it didn't come to your mind as a student that A is 6 and R is 3, just do write the first 3 terms. If R is 1, so this is 2, 3 to the power of 1, which is 6. Second term, when R is 2, 2, 3 squared, 2 times 3 squared, which is 18. When R is 3, 3 cubed is 27 times 2 is 54. You will notice that 54 dividing by 18 is 3. 18 dividing by 6 is 3. So we know that 8 is A, the first term is 6. And the common ratio is 3. And what does he want here? He wants sum of the first, or the 10 terms, because he gives us n is 10 in this notation. So just we write the formula and replace the values of A and R using the calculator. You're getting the sum of this is 177,144. Last example, my dear students, for now, for today. If the third and the fourth terms of a geometric sequence are 6.4 and this is and, it's written R twice, $5.12 respectively. The third is this, the fourth is this. Find the common ratio in part A, find the first term, part C, find the sum to infinity of the series. Find the sum to infinity of this series. Okay, the same logic like we did it in the previous example. You are given third and fourth. You just write the notation of third term, which is A R squared. Fourth term, which is A R to the power of 3 or R cubed. Write the values given. What you'll be getting? You'll be building or writing 2 equations. This is equation 1, this is equation 2. Best way and easiest way when I do equations including powers is dividing them. Divide them. And divide, of course, the greatest power, the greater power by the lower power, dear students. To get R, this is the idea. We can do this in many ways, but we have fast or short ways and make it easy for us. This is the use of mathematics as well. So AR cubed, which is equation 2, dividing by AR squared, A with A will be gone. R cubed over R squared is R. Divide this by the calculator, you will get R is equal to 0.8 or 4 over 5. So you find the value of R, so this is part A, this is gone. Part B, he wants the value of A. First term, he wants the value of A. You replace R is 0.8 in any of the equations. I choose equation number 1. You can try equation number 2, you get the same answer. So A 0.8 squared, replace R by its value, is equal to 6.4. Divide this by 0.64, which is 0.8 squared, you will get A is equal to 10. A is equal to 10. Find the sum to infinity of this series. We write the formula, which is A over 1 minus R. Replace the values of A and R in this. So it's 10 over 1 minus 0.8, 10 dividing by 0.2. So the sum to infinity for this series is 50. We may have, my dear students, combined the problems, especially the pure, in pure 2. In the same question, they combine arithmetic with geometric. We'll do such problems, or real life problems. When we used to do start solving past paper questions, or doing full past paper problem, choosing the hard problems in this chapter. And again, I wish you, all of you, the best everywhere. And I wish I did introduce this chapter as simple as I can. You can communicate by asking questions, by subscribing the channel. I will answer your questions. Thank you so much.